In the last video, I talked about experiments 4.1 and 4.3. And in this video, I'd like to talk about experiment 4.4, which was the one with the different temperature water baths. In experiment 4.4, we saw that the saturated concentration of a solution can change with temperature. One solid B, became drastically more soluble in water at higher temperatures, while another solid A, did not become noticeably more soluble as temperature increased. So here we have a graph that should look very similar to the one that you drew in your lab book, with temperature on the horizontal axis and percent undissolved solid on the vertical axis. And those of you that had solid B during the experiment noticed that most or much of the test tube appeared to be a solid in the cold water bath. So that's what this end of the curve looked. That's the reasoning for this end of the curve. And then around room temperature, 25 degrees Celsius, maybe 30 or 40% of the test tube appeared to be solid. And then at 100 degrees Celsius, or maybe 95 degrees Celsius, all of solid B dissolved, which is why we have a corresponding value of 0 on the vertical axis. And then for the solid A test tube, I think those of you that handled that one saw that the amount of undissolved solid in the test tube did not appear to change regardless of what bath it was in, whether it was in the cold 0-degree bath, the room temperature bath, the warm bath, or the hot bath. Now, this curve, I need to stress, will not look like the next curve that you're about to see, which we visited in the last video, this curve right here, because the vertical axis is the percent undissolved. This curve we're going to look at next has percent dissolved on the vertical axis. So that's why there's a different slope there. So on this graph, you can see that the blue line has the steepest slope, and that is indeed the substance we used for experiment 4.4 was potassium nitrate. Because of this very reason, its solubility changes drastically as temperature rises. Once again, temperature is on the horizontal axis, and solubility in grams per 100 cubic centimeters is on the vertical axis. So the temperatures that we looked at during the experiment 4.4 lab are the 0-degree ice bath, room temperature, which is right around 24-ish degrees Celsius, then a warm water bath, which was in the neighborhood of 40s or 50s, most likely, and then a hot water bath. So that was solid B, or test tube B. And then test tube A was this yellow line, sodium chloride again. So you note that at temperatures below room temperature, sodium chloride dissolves better in water than potassium nitrate. At room temperature, their solubilities are really quite similar. The yellow and blue lines intersect around room temperature. At temperatures higher than room temperature, potassium nitrate is much more soluble than sodium chloride. Now, the objective of experiment 4.4 really was to determine if we can use temperature as a means of differentiating substances when it comes to solubility. So two substances like potassium nitrate and sodium chloride may have very similar, if not the same, solubility at one temperature, in this case, room temperature, but very different solubilities at different temperatures. Um, Now, solubility can still be a characteristic property, you might remember, because characteristic properties do not depend on size, shape, or amount. The characteristic property definition says nothing about temperature. So the characteristic property can depend on temperature. Just as we saw with boiling point can depend on uh, pressure or elevation, um, but it still satisfies the definition for a characteristic property.